We are on the section 2.6, page 48. Okay? We are going to talk about something called second derivative, okay, and concavity. This concept is somewhat difficult for you, all right? And we will use it for some applications, which is kind of critical for the things you are learning, okay? We are going to learn this, use second derivative. We use f prime prime, right? And concavity to figure out how a function behaves. Why do we care how a function behaves? Because the function is the model you are using for many situations, okay? You will see. So for economies, for other things. So for second derivative and concavity, usually I have to think twice to sort of things out if I haven't done it for a while, all right? If it takes me, twice to sort it out, it may take you many times to kind of follow, and you may not be able to sort it out. But if you cannot sort it out, you will remember the conclusions we are going to make, so you can apply to the problems, okay, to solve problems. But we are going to talk about the thinking behind it, why we would draw those conclusions, okay? Just try to follow as much as you can. So, we have been studying what? Functions, because functions are your models, okay? So to solve problems. And so far, we have been learning what? Derivative, right? The skills and the tools to find derivatives, okay? First derivatives. And we wanted to understand functions, okay? So for us to understand functions, we study derivatives. Then you will find out why in this section, okay? Then let's figure out how derivatives behave, okay? So we talk about derivative, right? Derivative is what? The rate of change, right? Then, if you have a function, the change on the function is what? The rate of change is your f prime, right? We say, what is f prime? is the rate of change, right? Or the tangent line of the function, the slope of the tangent line. One time we talk about those, okay? So f prime is the rate of changing. If it's bigger than 0, it means what? It is positive, okay? So we try to follow what is derivatives. How do they behave? Then we go back to functions, okay? So let's just study the f prime first, okay? So we are talking about if my function f of x, which is y, all right? Then let's talk about the slope, okay? Before we'll talk about y is the function. Then let's talk about let's write it this way. The slope of f, right? So your y is f of x, right? The slope of f, if f prime is bigger than 0, that means what? The derivative is positive, right? It means what? The rate of change. The rate of changing is positive. That means what? The rate of changing, it means the change for y, right, is positive. That means what? That means y is getting bigger, right? Because your y changing is positive, that means next point is bigger than this point. So the changing is positive. That means y is getting bigger along the way. That means what? F is increasing, right? So then let's see some examples. That means if from this point to that point, right? That's your y. X is your reference along the time frame. So there are two situations. So you have from this time to next time, the f, your curve is increasing. Let's do the simple curve, okay? So if it increase, then we are not talking about straight line. That's too simple, a linear, right? So if it's increasing, next point has to be bigger than this point, right? So it has to go up. So it can go up this way, right? Like this. Or it can go up like this, more slowly at the beginning, but it ends up higher, right? So we are talking about this f function. Is this a function? Right? Vertical test. So from point A to point B, the first y is here, then at the next point, y is there. So if your value increase along the time frame, you can increase fast and slow down later, or increase slow and fast later, right? So if the growth go like this, then we call this graph, we call it what? Concave down, right? So it's concave down. And this one goes up like this. We call it concave up. So we are talking about concavity, okay? So when from point A to point B, if it's a growth, and the way it grows and can be this way or can be that way. At this point of time, if your function f equals y equals f of x, right? Then either way, when you find the derivative, your derivative will be what? Bigger than 0, right? Because the rate of change is what? All positive. Okay? If the rate of change is positive, means what? The change for y is positive. That means it's growing. It's growth, right? And the shapes can be that way. So this is the first one of the characteristics, okay, for f prime. So if f prime is less than 0, means what? The rate of changing is negative. Means what? Next y point is lower than this y point, right? So it means what? The rate of change is negative, means what? It decreases. The change, we say f prime is the rate of change, right? So f, right? The rate of change for y is negative. That means what? Y is getting smaller, right? So the y is what? F is y, right? Decreasing. So if you look the graph of the function, that means from this point and you don't have a growth. You might have loss, right? From here point to here. But two ways to get there. So you might get there by doing this, right? You might get there by doing that way. That means this one drop fast and get there. This one drop slow, but still later on drop more fast. So when you have this situation, like shape like this, we call it what? Concave look like. Up, right? Then this one will be what? Concave down. Okay? So we are saying how a function, a model behaves, and by looking its derivative, then we can see. Okay? Then another one is saying if we have bigger than 0, smaller than 0, I can be 0, right? That means what? The rate of change is flat. It's not changing, right? At that point. So at some point of time, x, not all of them, right? F prime is 0. Usually we talk about at some point of time. At some point, okay? So it may look like this way. That means the slope is 0. Okay, so you may look at it like this. If you have a market fluctuate, right? Fluctuates like this. Okay, then at this point, its tangent line f prime is also a tangent line, right? The slope of the tangent line, we should use that. The slope of the tangent line. That would be 0 at this time, at this point, or at this point. Okay, how do you look at the tangent line? Is like if you tied a rock and with a string. Okay, so if you hold that rock, then you make a circle on the top of your head. If you throw it, okay, then when you release the line, the rock will fly away, right? If at this point you release the line, the rock will fly that way. If at this point you release the line, right, then the rock will fly that way. Or at this point, you will fly that way. So those are the tangent line you are looking at for a curve, right? So for when the slope of tangent line is 0, means when it flies out, it will be on the level. So if to here flies out, will be on a level like that. Okay, then at this point, the tangent line will be f prime. At that point will be like those. When it happens this way, if your function model fluctuates like this, then at this point in time, you have what? Relative extrema, we call it. This would be relative maxima. This would be what? Relative minima. So we call them what? Relative extrema, right? You have this situation. Okay, that's one situation. And you might have another type of a situation. So it might be like this and like this. Okay, so just like you threw a string with rock, you threw this, it will fly out like this, right? Then for this one, for this point, to be able to have f prime from both sides, you have to have same value, right? So you threw this one, it will fly out that way. So you do have a tangent line at this point, okay? However, this f prime will be what? It's increasing like this. So it will be bigger than 0. This one still, that would be like this. This one still bigger than 0, right? Then this one, we call this situation, we call it inflection point, okay? Another situation is like this, okay? If you have curve go like this, you throw a rock out, the rock will fly level, okay? Then if this one, it will look like this, and at this point of time, you will have the tangent line is 0. When you have this situation, but this one is what? F prime is less than 0, and this one, F prime is less than 0, right? So when both sides through that point and both are positive or both are negative for your derivative, those then those points we call them what? Inflection points. Okay, so we are talking about how F prime behaves during certain model situations, during certain functions. Okay, and another situation we talk about F prime is a number, right? Can be bigger than 0, can be smaller than 0, can be equal. Another one is what? Undefined. Or we say it doesn't exist, right? So what does that mean? Okay, it means F prime has two conditions. One is just doesn't exist, means what? Vertical line. And same thing means what? Vertical line. Okay, equals E. So you have vertical tangent line. Okay, let's see. What kind of condition it would be doesn't exist? What condition it would be vertical tangent line? Okay, so if you have your market fluctuate like this, right? So is this a function? Yes, it is. Okay, so for those points, and what happened? It's still a function, right? And it is continuous, but no F prime, right? We did earlier for those because two sides numbers, the slopes are not one number, right? Because those two slopes are not the same, okay? So we don't have derivatives, right? Because your limits from both sides are different, because we say, okay, the limit for f of x from the number to this number from left side is different from the number from the right hand side, right? Because we say if the derivative exists, the both sides should merge to one number. Okay? So this condition, then we don't have the derivatives, right? That means if my market fluctuates like this, then I cannot use my derivative skills to solve certain problems. Okay? And we have another two situations. We will have tangent line. All right? So if my market goes up like this and goes up that way, right? So here, if this shape, that would be this shape. So f prime is bigger than 0. then this one is what? F prime still bigger than 0, right? But it's concave up to concave down. Then when you threw the rock, think about it, if you threw the rock at this point, then the rock will fly that way. Same thing as this point, right? So at this point, we call it what? Do we call it inflection point? Not really, because we don't have derivatives. Okay? And inflection point is talking about when we still have derivative of what? 0. Okay? If we have a situation like this, if it comes down, then go there, right? So when you have situation, this one is what? This shape, right? So this one F prime is less than 0, and this shape is going down, so F prime is still less than 0. But at this point, if you threw the rocks this way, then you will go down, right? If you threw this way, you will go that way. So you have a vertical tangent line. So if the line is a vertical infinity, right? F prime, then you don't have, because your slope is what? Vertical line, and it's undefined. Okay, so we introduced the F prime first, right? So this one is what? F prime is bigger than 0, first one, right? This one is F prime is less than 0, and this one, or this, right? F prime equals 0. Then here is what? F prime, not the prime, is undefined or doesn't exist. Okay, so we are talking about the behaviors of the F prime first. Okay, and the curves look like those. Then that means your functions, your models, you know, the growth, how the market may fluctuate. Then we follow through and see how we are going to use F prime to figure out something. All right, then, so next one we are talking about something called critical numbers. What are critical numbers? Is talking about a function, okay, is at x at some point of time in of the f, right, f of x, at some point of time, then f of x is your y, that will be, say, your market values, okay? But at the point of time at x, and in which, at which, if, at which, okay, if at that time f prime x is 0, then, or f prime x is undefined or doesn't exist, then we call those points of at this point of time, at x, we call this one is what? Critical numbers. So critical time. Critical numbers means what? The critical time. Okay? Like at this time, your market value is the highest, relatively highest at the time, or your market value is relatively minima at the time. Then we call those what? Critical times, right? Then here we use, in math, we call them what? Critical numbers. Okay? So let's see how we are going to use critical numbers to decide things. So these two situations, f prime is 0, okay, or f prime is what? Undefined or doesn't exist. Those are critical numbers, okay? Then we use this to decide a few things. In next one, we are going to talk about concavity and IPs. Concavities and IPs, inflection point. Okay, so an inflection point is the point on the graph, a function where the concavity of the function changes from concave up to down, or from concave down to up. Okay, so inflection point we are talking about are those, like it changed the shape of the concavity. So like this one, concave down to concave up. So at this point, we call it inflection point. From here, concave up to concave down, right? And for this one, concave up, concave down. Then concave down to concave up. But this one, the derivative doesn't exist. Okay? So, if f prime bigger than 0, right? So that's a talk about concavity and IPs. So for the concepts, so on your page 49, okay, so the concepts are what we are talking about. If f prime is bigger than 0, so we have these two shapes, okay? F prime, this f prime bigger than 0, right? These two shapes. If f prime is less than 0, that would be what? This shape, okay? So, there are another things we want to talk about is, let me just write it here. F prime bigger than 0, so you have concave up, going up, right? Concave down, right? And let me just redo those. Let me summarize here. F prime is bigger than 0, from point A to point B, it goes up, or going, oops, that's going down. No. Okay, so it's still going up, right, for a function. So this one is what? Concave up. This one is what? Concave down. All right. Or I have f prime is less than 0. We are still repeating, right? Your change, the rate of change is decreasing, so you drop for your y. So you will have this one, right? Or you have this one. So this one is what? Concave up, concave down, right? So for both of them, for the derivative, it's a positive or negative, and both have concave up and concave down. Okay, now let's look another situation. We want to talk about something. Okay, let's analyze that. Okay, if I have a curve like this, so start from what? Concave up, change to what? Concave down, right? So it's like this way. It goes from up to down, right? Up to down means what? Your f prime is what? Less than 0, right? From point A to point B, if it dropped, right? That means the rate of change is negative. Then this one, it goes up, the rate of change is what? Positive, right? So it might be what? When it drop, so it might be what? F prime can be -3, -2, -1, right? And here it goes up, can be, slope can go higher and higher, right? So this one, f prime can be 1, can be 2, can be 3, like this. So in between, so our f prime is what? F prime can be something to -3, -2, -1, right? To the point here, f prime is what? 0, right? Then to 1 and 2 and 3 and on, right? So in a way, this one is less than 0, this one is bigger than 0, but your f prime is what? Increasing. So what do we have? If we have this shape, your model is that shape, then your f prime is what? Increasing, right? If f prime is increasing, so it means what? The rate of change of f prime, right, is what? Is positive. Is that right? Because f prime itself is increasing. So the rate of change for f prime is positive. So the conclusion is what? F prime is the change of the f. Then f prime prime is what? Is the change of the f prime. So f prime prime is what? The change is called the rate of change of f prime, right? So f prime prime is what? Positive, greater than 0. Okay? So you will see what we try to drive to. All right? So if I have a model, a function, the graph looks like this way. It means what? My f prime prime is positive. Okay? If I have things like this, if my market fluctuates this way, and let's see what will happen. So this part is what? From low to high, so the change is positive, right? F prime is positive, like this. Then if like this, from high to low, and it's like this, my f prime is what? Less than 0. In between, my f prime is what? 0, right? So it's what? It's like 3, 2, 1, 3, 2, 1, and getting to 0. Then less than 0, right? The slope, if it's dropped from left to right, means negative, right? So then that would be -1, -2, -3, right? So our f prime would be what? Would be like, okay, to 3, to 2, to 1, then 0 to -1, -2, and -3, right? So what happened? So your f prime is what? Decreasing, right? From high number to the low number. So what do we have? The rate of change of what? F prime, okay, is negative, right? Okay, that means what? F prime prime is what? Negative, less than 0, right? It means what? F prime prime is the rate of change of F prime. Okay? So what are we talking about is second derivatives now. From F prime, the first change, the rate of change for your model, then we talk about the derivative, how first derivative, how it behaves will impact the second derivatives. Okay, and when this situation happened, okay, look at this. This curve, this one, these two curves, both concave up. This one, what? Both concave down. Okay, then let's summarize it. Okay, so we will draw such conclusion. Okay, if you have a trouble to sort it out all this, okay, if it's too confusing for you, that's okay. Okay, this is just concepts behind the conclusions we are going to make, but you need to memorize all these conclusions. That's kind of important. All right, so when we have f prime prime bigger than 0, see, when we have f prime prime bigger than 0, that would be this shape, right? So this shape is your function f. Then f prime is those numbers, the what? The rate of change, the slope of the tangent line, f prime, okay? Then change from less than 0 to bigger than 0. But either sides are concave up. So for the f, so when f prime prime is bigger than 0, your function f is what? Concave up, right? Like this. If f prime prime less than 0, see, f prime prime less than 0, it would be this shape. So your f is what? Concave down. Okay, why do we care? You see, if your market fluctuates like this, that means you hit what? The bottom. If your market fluctuate like this, then you hit the top, right? Then you make decisions that way. Then by figuring out what? F prime prime. Okay? When you have concavity changed, those are just same always. Same always. Concave up, concave down. But if you have this one, concave down, concave up, or concave up, concave down, right? Or like this, you have this one, right? Concave up, concave down, concave up, right? So when you have concavity changes, the point will be what? Then you will have IP point, right? That will be your inflection point, right? When you have an inflection point like this, okay, or like this, we call them IPs, inflection point. Your F prime prime will be what? 0 or what? Undefined, or doesn't exist, like this. Is that right? Okay, right? And let's see some, maybe a quick example, okay, to see those situations. So if you get confused with all those, it's nice to sort it out. And if you go for the further study for your economics, okay, it might be handy sometimes. So let's see. If we just use a simple model, okay? So if I have this one, example, okay, if I have f of x, this one is not on your paper. If my f of x equals x fourth power, if you do your t-table, use your calculators or use website, so you will find out the curve. It's like this, right? Both what? Concave up, right? So the shape is concave up. So let's take a look. F prime of x, you use your skills to do the derivatives. That would be 4x cubed, right? So we are interested in, at this point of time, x is what? 0. So f prime 0 is what? 0, right? How about f prime prime? You take a derivative of this, that would be 12x squared. You take f prime prime 0, that would be 0. So f prime prime is 0, right? So when f prime prime is 0, that means you have what? At this point of time, you have minima or maxima, okay? So when we have this situation, and what do we have? When you have f prime, okay, c is 0, it means what? It means you have relative maxima or minima or IP, right? We saw it earlier, so we have f prime of c. We have this situation, right, earlier. So change here, rate of change at this point, right? This f prime at this point is what? Is 0. This f prime is 0. So when f prime is 0, it's a relative minima or maxima, right? Or we have this situation, right? So your IP point, or we have this one, right? So this is your IP point. So at this time, your f prime is what? 0. Is that right? We saw it earlier, right? So when you have f prime is 0, you have what? You have relative minima or relative maxima or IP point. Okay, so that's what we are talking about. If I have a model like this, then at this point of time, my f prime is 0, right? But my f prime prime is 0, right? That means what? I have, at this point of time, I have what? At x is 0, okay? Y is what? A minimum, right? You can see that for this model. But my f prime prime is 0. So we are talking about what? When f prime is 0. Okay? And look another example. If I have this one, f of x equals x cubed. So, right, the graph, when you graph it, it will look like this. Right? So we are talking about some critical point, right? CNs. Okay, so f prime is 0 at this time. So we do f prime x would be what? 3x squared, right? Then f prime prime x would be what? 6x, drop one level, right? Then when we do f prime 0, that would be 0. F prime prime 0 is what? 0. But at this time, okay, at x is 0, what happened? Okay, and y is what? Y is an inflection point. Okay, so we are just give you more examples for when f prime is 0. We are going to use this property to solve problems. Okay, so you have what? Minimum. You reach a minimum, right? So if your market fluctuates, you reach a minimum point, then your life changed, right? And for this one, if your market goes this way, this point, we call it what? Inflection point. And see how it works out on a real world. Okay, let's repeat what we have been learning. Okay, so if we have f prime for the point, say f prime is 0, okay, at a certain point of time, say, then what kind of conditions we are in, okay? We are talking about first derivative and second derivative. Then see what kind of things will be used, okay, with those things, with the f prime and f prime prime. So when f prime is 0, it's like this, right? And at this point of time, your f prime is 0. Or here, f prime is 0. We can use the for what? Like maximum profit. If your profit curve is this way, that point will indicate the max profit at a certain condition, right? Then this one, lowest point, it can be used for what? Like a minimum cost, right? And we also learn what? We have this f prime prime greater than 0, f is concave up, okay? So like this one is concave up here, right? This is a concave up. So it indicates at this point, f prime prime will be what? Bigger than 0. Then at this point, f prime prime will be what? Less than 0. So you can use those conditions to decide you have what? Relative maxima situation or relative minima situation, okay? And sometimes f prime is 0, it might be what? IP point, as we say here. Then what is a IP point, right? What is an inflection point? We said on your previous page, let's take a look. On your page 48, here is saying when an inflection point is a point on the graph of a function where the concavity of the function changes, okay, from concave up to concave down, or from concave down to concave up, okay? So for this situation, it will have a few things. So it might be what? Concave down to concave up, right? Like this. Or concave up to concave down. At this point of time, okay, then your prime, f prime, you know, it's your tangent line, you shoot it out this way. You shoot out this way. So your f prime is 0, right? Same thing, you shoot it out this way, that's your tangent line. Shoot out this way, that's your tangent line. So this f prime is 0. So those are IP points, right? Because concave down, concave up, concave up, concave down. Situation changed. Then we are going to see some more real-world examples, how those things will be used by economists, okay? So another situation is like this. So you have concave up, right? Then concave down. So it shoot up at the point here, then its tangent line is like this. Then here shoot it out will be like this. So this is your IP point. Then your f prime is what? Undefined, right? And it might be what? Let's see, concave up, concave down, or concave down to concave up, right? So at this point, then you shoot it out would be tangent line, shoot it out would be tangent line. So you have those situations. Then let's see when the market fluctuates like this, then what does it mean to the investors? Okay, so we are going to look those situations. So what we are talking about is using f prime and f prime prime. Okay, f prime prime, like those. So we find out, okay, how to use those f prime prime to determine situation, then see how we are going to make sense of it. Okay, so that's what we have been learning, right? And if you cannot really sort it out, what's the reasons behind all those conclusions we have here, as long as you can remember those, f prime equals 0, it means what? You have relative maxima or minima or IP points, right? For f prime is 0. Then when f prime is undefined, okay, like this, then you have what? This one, f prime is 0. That's for this case. When f prime is undefined, then we will have IP point like this as well. Okay? But f prime prime for those things, maybe, a little bit different. Let's find out how it works out. Okay? So, we did earlier, we give you different examples, okay, for the equations. So we say if f of x is x fourth power, right? Then we have what? F prime would take a prime, that would be 0. F prime prime would be 0 as well. The graph, it looks like what? It looks like this way, right? So it says what? At this point of time, the value of y will be what? Y is at when x is 0, y is minimum, right? That means when f prime is 0, you have what? Relative minima. Okay? When we have this example, x cubed, right? And what do we have? F prime 0 is 0, f prime prime is 0. The graph looks like, if you use calculator, you will find out. It looks like this, right? So that will be this condition. Okay? So your f prime is 0, f prime prime is 0. So at this point of time, your y is not minimal. Okay? Your y is what? At this point of time, and y value is an inflection point. Okay, so it's a little bit confusing when f prime is 0. It can be minima or maxima, or can be what? IP point. So that's what we are talking about. Okay, then let's see some examples for those. So look at your page 40, example 1. Okay, even we repeat many times, you will still get, kind of confused with it. Okay, just go with it, then see how it works out when we see some real examples. It might help. Okay, so here says graphing and interpreting a company's annual profit function. So a company's annual profit after S years, oh, shouldn't be S years, should be what? $1 million. Okay, after X years. So the model is saying, okay, and this is the one given to you. Somebody did a study. Okay, they realized the company's profit will behave this way after X years. Okay, so X is the years. Okay, how many years? Then X is bigger than 0. Okay, then f of X is what? $, right? For millions dollars. Okay, counted by million. So, okay, let's see what does it mean. Graph this function showing all relative extreme points and inflection points. Interpret the inflection points. Okay, so you will use calculator to do this. X will be your what? Years, right? Then Y will be your what? Dollar in millions, right? So your Y is your f of X. Then f of X, the function, is your model. Okay, so if you do it right with calculators, you will find out, okay, you have to adjust your region and range for the X and Y's. Okay, and call the tutors to figure out how to use calculators to adjust the range if you have issues. So then you see when it's 2, you have things like this. When it's 4, you will have this. Okay, so you will look like here and here and up. Okay, so when you plug in 2 at year 2, what kind of a profit the company will make? You plug in 2 to the third, 8 minus 36 plus 48, right? You get somewhere like 2. Okay, then let's use the things we have been learning called what? Derivatives. F prime, first derivative, and prime prime is second derivative. Then see what this means, okay? If you plug in the value, let's talk about this graph first. Plug in the value, F0 would be what? First year, year 0 you started, you make no profit. So first year you make what? 16 mil. Second year profit goes to 20 mil. And so you increased by 4 millions. right? Then third year, you make 18 millions. That means what? Your profit dropped, right? That's what it means. It dropped. Then fourth year is what? You make 16 mil. Then profit dropped. Okay, according to this function and the model, it tells you this. Okay, then let's see if we use f prime, we have been learning what does it tell us. Okay, so if f prime x will be what? 3x squared minus, multiply, right? 18x plus 24, right? Then f prime will be what? F prime will be 6x minus 18, right? Then we say we use f prime is 0. Let's see what happened. So if my f prime x is 0, that means this way, right? So it means what? Fx, 3x, 18x plus 24 is 0. Then we solve for x, right? Then x is the years along the way for the company. So if we solve it, that would be 3x squared, do your factoring, right? Plus what? 8. Then you factor it, x minus 4, x minus 2, right? Equals 0. That means what? X can be 4, x can be 2. Right? So what does it tell you? It tells you, okay, and those are your critical numbers. So f of c, when it's, look your page 48, okay? So critical numbers, so f of x, f prime or x equals 0, that means at the c, those are called critical numbers. Critical numbers means what? The situation for the company will change in certain way. Then let's figure out what do we mean by certain way, right? So after we have the f prime is 0, we have to decide it has what? Relative minima, maxima, or IP. Okay? So then we use f prime to decide. So you do f prime, right? F prime is this. So you do f prime at the point year 2. So your f prime 2, you plug in here. That would be what? -6. Okay? At x equals 4, your f prime 4 would be what? 6. Then we have to see what will happen. So we say at this point, this is less than 0. So what does less than 0 mean? Okay, so it says f prime is less than 0, then the function itself, okay, the f itself is what? Less than 0, right? Concave down, right? So if you have concave down, it means what? You have what? A local, looks like this. So you have a local maxima. Okay? So if it's bigger than 0, that means what? F is what? Concave up, right? looks like this, then you have what? A local minima, right? And also we have another situation is this, okay? So we have to decide at these 2 points, then if f prime is 0, then if f prime prime is less than 0 or greater than 0, then you have local maxima or minima, like those, right? And when you have f prime prime is 0, what will happen? Okay? So, then if f prime prime is 0, if this one, f prime prime at this point of time is 0, for the second one, 6x minus 18, then what do we have? You solve for x. X is 3. So when f prime prime is 0, what does it tell you? When f prime prime is 0, it means what? At x is 3 and f has what? An IP, inflection point. So it's saying at this one, at this point of time, when x is 3, at year 3, it means IP point means what? You will change what? It's changing concave down to concave up, right? So what does it tell you? It tells you at year 2, you relatively make more profit in before and after comparing, right? At year 4, you make what? Minimum profit compared to a time before it and time after it. Then what happened to the inflection point? What does that tell you? Okay, so IP point is telling you this, okay? Let's write it down so help you to remember. It's saying the IP point at year 3, right, is where the profit first what? Start to change, inflect, right? Inflection. So the profit first begin because it was dropping from year 2 to year 4, right? So at year 3, then first began to what? Show some signs because it's dropping, okay? Dropping quickly, then slow down, okay? So to show signs of what? Improvement is telling you. So it marks what? The end of period of what? Increasingly steep decline, right? Because after year 2, local maxima, so it start to decline, okay, until you hit the relative bottom of the profit you would like to make, right? So it will mark the end of period of increasingly steep decline, okay, and the first sign of and we say upturn, right? So when situation happened like this, where a clever, we say, investor might begin to buy in. Okay, so if you are investors, then you might want to look the company's prediction with their modeling, hopefully, right? Then you buy at a lower point and make a profit at a higher point at the time, right? It's kind of complicated. Okay, let's look at some inflection points in the real world. We are on the page 50. Okay, so for each curve, is there an inflection point? Okay, so inflection points mean what? Concavity changes, right? So if we have a situation like this, if one is this one, so is this an inflection point? These both are concave up, right? So it is not. Okay, so and if you have situation like this, changed, right? Is this point an inflection point? Yes. Why? Because it was concave down to concave up, right? So inflection points mean what? When they change the concavity. So that's what we are talking about, right? So let's see. So for the first one, if you have this, okay, year 1, 2, 3, 4, 5, like this. Then they make millions like this, okay? Then if the model, it shows, okay, it goes just like the sample we have earlier, right? So it goes like here, here, and here, right? And here and up, just like the example we just went through on your page 49, right? So what does it tell you? So this is the IP we have, right? Because f prime prime is 0 at this point, okay? So it says inflection points occur in many everyday situations. The graph on the left is typical of a company that is first prospers, right? Prospers, then what? Falters, then recovers, right? Like this. The inflection point is the first sign of recovery, and it is where a smart investor might purchase the company before the recovery becomes obvious. Okay, this is one type of a situation for inflection points. Okay? Then let's look another one. Next one, it shows graph like this. Then start from year what? 2001, then 10 years. Okay. So if the graph look like this way and here, so it goes up. Okay, must be a new company from 2001 because the what? Oh, this is Wikipedia articles. Okay, it's in millions dollars. So for Wikipedia's article, and this is a source from actually from their organization. Okay, so they started from here, they make 0 million, right from here, then they start to grow quickly and somehow slow down like that, right? So what does it tell you? Let's see. It says this graph shows the number of articles. Oh, it's not $1 million. It's what? Millions of what? Articles. It shows during those years how many articles, how many millions of articles. Only what? Wikipedia. That's what it's saying. Actually, it's the data from their organization, right? So they actually record all their data and do the graph. So what does it tell you? Okay, so the number of articles in Wikipedia in English for recent years. The inflation point actually happened every 2 years, 2003, 5, 7, 2007, 2009. They say the inflection point, right, in 2008 happened here, marks the end of increasingly rapid growth. So they grow very fast here, right? They grow very fast. And because that's concave up, okay? And then what? The beginning of the slowdown. They start to slow down, okay? Then that is in later years, they will still begin because they are still increasing, okay? F prime is greater than 0 at the time. There will be still gains, but they will be smaller and smaller, okay? So, it's saying in business, a point of diminishing returns is a point on a revenue or profit curve where further investment will bring decreasing rather than increasing return. But you still gain, but, right, it was rapidly gaining, okay, concave up, then you start to slow down. Okay? So, for those IP points, it shows what? A point of diminishing returns. Okay? So, geometrically, it is an inflection point where the curve changes from concave up, see? Concave up to what? Concave down. As in the second graph, on this graph, all right? It represents the end of growth that is accelerating and the beginning of the growth that is slowing, right? So in practice, given a particular function, we find its point of diminishing return by finding what? here f prime prime as this year is 0. Okay, if we can find f prime prime, this is 0, and it means sometimes, not always. Okay, then it is what? A point of diminishing returns, which is very critical for a company, right? Especially big company. And checking that f prime prime change what? From positive, it was positive, right? To what? Negative. Because f prime still up, means f prime is the rate of changing for f, so still up, right, from point A to point B. But for the f prime still going up, but f prime prime is the rate of changing on the changing, right? So the changing is still increasing, changing on changing still increasing, but here changing on changing start to decrease, right? Not too bad, right? Not as confusing as it looks as earlier, okay? And let's see some more inflection points in the real world. Okay, so the inflection points happened, okay, in many everyday situations. So let's look at the next 3 examples, and actually they are all real, okay? So from their, company's data. And here, first one you look at is this one, okay? It looks 2, 4, 6, 8. It has what? It goes up and come here and go up, right? Then here you can see sort of this one, because you have top point to the lower point, you have to change it some point of time, right? So this one look like this, right? To a point, it will, oops, that's concave down, then this is what? Concave up, right? So in between, there would be your IP point. If it's IP point, your f prime prime will be 0, as we discussed at the beginning of this section, the confusing part of reasoning, okay? But as long as you can remember all those summarized conclusion, okay? Here say that's year 2000, okay? 2002 here, 2003 here, 204 here, somewhere there, right? Then this one is $billion. Those are the years from what? Year 2000, say. Okay, what do we see here? And this source is from Standard & Poor's. So it's all formal data, okay? So it says the function in this example, while constructed for ease of the calculation, is essentially the graph of net income for AT&T. Okay, so this is for AT&T over recent years, shown on the left, shown here, this graph. Notice that inflection point represents the what? The first sign of upturn, so it was profit dropping, okay? Then it start to pick up again, because once you go concave up, you have to go up, right? Then represents the first sign of upturn in AT&T's net income, which occurs when? This year, okay? 2003. That's what happened. Let's look at the second one. The source is Consumer USA 2008 for the MP3 players. See what's going on, okay? The graph, it shows what? How many sales for the MP3 players. MP3 player is an electronic device that can play MP3 digital audio files, okay? So, like those mobile music people use, right? So, okay. So, it shows what? Say from year 2000 and 2, 3, 4, 5, 6. Okay? So, it started very slow. Then, 1, 2, 3, 4. Okay. It goes up. So, concave up. It means what? It keep going to a point. Oops. Then start to concave down. So concave up to concave down, it changed the concavity. So this would be your what? IP point. At this point, 2004. Okay? So what does it tell you? The graph on this one shows the annual sale of portable MP3 players. The inflection point occurring between 2004, okay, so it's a little bit after 2004, between 2004 and 2005, okay, between these 2 years marks the end of period of increasing rapid sales growth, right, at that time, and the first sign of approaching market saturation. Okay, so when people, start to buy to a point, all the buyers, start to slow down. And this when savvy manufacturers might begin to what? Curtail new investment in MP3 production. So at this point of time, the manufacturers, okay, we think, okay, you will not sell that much, so you don't produce that much. Okay, so you beyond those points, you will still begin. You still have more sales than before, but with what? A slower rate. So that's what it's telling you. Okay, look at the next one. Next one looks like this. So start from here, concave down, okay, then start to what? A little bit concave up, like this. So you have what? An inflection point. Then this is what? Millions sales, and those are years. Let's see, for what? Okay, the source is from what? Euromonitor. Okay, so it says the graph on here shows the annual sale of what? Analog cameras a few years after the introducing of digital camera, right? So this one is showing what? The sales of analog camera. So, but once digital cameras came out, now it's like cell phone, right? So hardly anybody use the analog cameras anymore. So the inflection point occurring in 2004 at this time, okay, marks the end of increasing steep sales decline because they keep dropping because everybody's using what? Digital camera. But at this point, then it still dropped the sales, but not as bad as before, right? And the first sign of what? Steadying but lower sales. but start to slow down. Okay, so you can read from the applications of concavity to economics. So if you do further study on economics, then you can read those articles and for concavity. Okay, so it relates to what we have been talking about, right? Does that make a little sense, better sense for you now? Let's look at another example on your page 51. Finding a point of diminishing returns. Okay? And a company predicts that if it invests X thousands dollars, right, in advertising, its revenue would be this function. So they modeled their what? Profit or revenue? The revenue, okay? Revenue this way. $100,000 for this one. Your X is 0, between 0 and 9. Okay, what does that mean? What is the X? Okay, so X is what? Look at the question, is the $100,000 invested in advertising. Okay, so they invest what? Between 0 to $900,000. Okay, then it's modeled this way. So we want to find what? Find the company's point of diminishing returns. So what does diminishing returns mean? Okay, that means you make a lot of money, then the revenue you make start to what? Shrink or weaken or lessen, right? Start to slow down. That's what I mean. So how would you start? So what you wanted to do is, this is the model. So we will visualize first. So you will use what? The calculator to graph it first. Then try to make a little bit sense of it. Okay, so it's 0 to 9, so you need to adjust your calculator to those numbers. So X is what? Is thousands, $100,000 in advertising, right? So you have 500,000, 10,000 means a million. Okay, so it's between 0 and 9. So if X is 0, you invest $0. So what's your return? Is the revenue. Okay, revenue is $100,000 as well. Okay, so if 1 here means what? $100,000. So it's what? 100. If X is 0, if they invest $0 in investment in advertising, they get what? $100,000. So $100,000. So, right? So that shouldn't be this one. So this is, so that would be $100,000. So that would be what? 10 million. That's what it means. Okay? So if you graph this one, you plug in 5, it will be somewhere here. So the graph will look like this if you graph it. So it's somewhere there. You have to actually do it. All right. So 20. So your graph would look like this one. Okay. So you take a look. Here would be what? Concave up. This would be what? Concave down. Then in between, something must have changed. Otherwise, you cannot go from up to down, right? Somewhere in between, something will switch, okay, from concave up to concave down, there. Okay, so that's to find out. So for diminishing point, right, diminishing returns, that means you need to find a what? An IP thing, right? The point. So because it changed the shape from concave up to concave down, when you have changing on concavity, then IP happened, right? So we want to find this point. That means you grow very fast, then the growth will slow down. So we want to find out what? The IP. So for IP point, then f prime prime is 0 for this case. Okay, so what do? So we need to find the f prime prime. So we find the prime first. So you take a prime on the revenue, that would be multiply 6x squared plus 2 times 60x, right? Then we do r prime prime. So doing it is not too bad. If you have IP point, right, you have to, most of the time, your f prime prime is 0. So because you shoot up, you can see, and let's see what will happen. Okay. And f prime prime will be what? Negative 12x plus 60. Then you make this 0, right? So that would be your equation. Then you solve and move x over linear equation. So your x is what? 5. So it means what? X is 5. If you invest $500,000, then your revenue returns will be what? Slow down. That's what it means. Okay? So find the company's point of diminishing return. That's it. Right? So let's just write down in words, then think about it. So IP at x equals 5, right? Then you will check, okay? So we will check a few things. What happened before and what happened after. So let's check r prime prime for equals 12, bigger than 0, right? Then r prime prime 6 is negative. So from positive to negative, you have to go through what? 0, right? That's our r prime prime is 0. Sometimes at inflection point, you might have 0 or undefined or doesn't exist, right? How do we know which one to use? Then you check what happened before and what happened after. It might give you some hint to decide. So between positive and negative number, you must go through 0, right? So we say the second derivative, right, changed from positive from the left, right, on the left hand side, okay, to the negative on the right hand side. So it means what? Positive is concave up or concave down. Positive is, so from what? Means from concave up to what? Concave down, right? Positive to negative, concave up to concave down. See? Exactly. Right? So it will give a point, given a point of what? Diminishing return. That's what we are talking about, right? Returns at that point. So how would we say it? So therefore, since x is in hundreds of thousands, right? $100,000, right? So the company at the 5. So x is what? 5. Did we get x? Yeah, here. X is 5, right? X is in $100,000. So company point of return, diminishing return we are talking about. Returns is what? $500,000. That means once the company invested $500,000, then the return, the revenue get from those investments start to slow down as not much as, the money you put in. So they can make a decision whether or not they wanted to invest more at a time, right? That's how the decision can be made. The situation is the function, the model is very tricky. Okay, how can you get that? Then that's a lot of research to figure out those things. Okay, then let's look at another one. Number 4. Say, okay, let's just do some practice for the skill. Okay, so just try to find the IP. Then if you have this function, so what do? you graph first, right? So if you use the range like -10, -20, so you use range like -30 to 30 for the y, then x you use, -3 to 3, things like that. So if you put a 1 in, so 1 in, so you should get 18. So 1 and 18, okay? If you put the -1 in, so you should get what? -18. -1, -18. Then, when you graph it, you will see the situation like this. Okay, so one thing is what? Concave up to concave down, then you will pass through an IP, right? Inflection point right there. So if we do it and use the calculator, you can use range from -2 to 2. Then y can use what? -20 to 20. You should see this. Okay? So we are just practicing the graph. Another thing you can do is just use what? Decimals and to see. But if you take the final exam in class, if happens, we will have to use the calculators, right? So let's summarize it again. Okay, so if we said if f prime prime exists, is defined, that means what? F prime prime, you can find it not undefined or doesn't exist. Okay, then x at c is a critical numbers. Okay, then what does it mean? So when f prime prime is greater than 0, it means what? It's concave up, right? So what kind of things we have? It means what? F has a relative minimum at x equals c. That's what we are saying, right? We have been doing that. So if f prime prime less than 0, so it's what? Concave down, then your f has a what? Relative maxima at x equals c. So how do we know f prime prime is defined? You just take derivatives twice. Do the second derivative. Then you can see whether or not you can get a number, right? If you cannot get a number, it's infinity, or, x is in the denominator, you cannot put it 0 there, then you cannot find it. But if you can find f prime prime, you will help you decide you have what? Minima cost, or you might have what? Maxima profit. Okay? So when f prime prime, so f prime prime greater than 0 or less than 0, it's relatively straightforward. But when f prime prime is 0, so f prime prime is 0, So situation gets tricky, okay? F may be a what? Relative minima or maxima. Okay? And or neither at this point of time. Okay? Then we have to take a look. Then on your paper, on the page 51, on the bottom, there are some, functions and models may, show you, it will show you this condition. But usually we don't have to worry about it, okay, for our practice. So most of the time we use those. We find f prime is 0, right? So we decide, we'll have a maxima or minima or IP. Then we know at that point you have this situation. Then you do the further derivative f prime prime to decide you have a minima or maxima. Right? Okay. Let's look the next example on your page 52. Okay, we are going to talk about the distance and velocity and accelerations. Okay, so we used this concept to do satellite tracking on one of the programs I worked on. Okay, so we used this concept. So let's see, what do we mean by that? So how far is the distance? We use this symbol. Distance, okay, is at the time t. T is your time. So then if you take the derivative of the distance, that would be something we call it, actually is a velocity. Okay? So, because what happened? An average change of distance is what? Your velocity, right? From point A to point B, how far it is, then you divide it by the time, then that will be the speed, miles per hour, right? How many miles you go through and how long it take you. If you average out, then that will be your speed, right? So if average change of the velocity, that would be what? So if you drive 50 miles per hour, average, right, to 60 miles per hour, so what's the change? 10 miles per hour difference in an hour, right? That would be what? Your acceleration. Okay, right? Then if we try to find, that's average. So if we try to instantaneous, okay, rate of change, instantaneous rate of change. At that moment, that would be what? The derivative. Okay, so the formula is this way. The distance according to the time, that will, we use S. the velocity would be what? The derivative of the distance. Right? We do instantaneous rate of change. Then acceleration would be what? Take a derivative of the velocity. That means what? The second derivative of the distance. So we use these concepts to do the next problem, okay? Probably we don't have those problems on your exams, I don't think. But you might have it in homework for you to practice the first derivative and second derivative. Okay, so here says, finding and interpreting velocity and accelerations. Okay, a delivery truck is driving along a straight road, and after T hours, its distance in miles east of its starting point. So go here, from here, go there. So the distance is described by this function. Okay, between 0 and T and 6. T is between 0 and 6. What is T? By the hours? It's by the hours. That means the truck drives what? Up to 6 hours. Eastbound. Okay, in miles. Right? So it means what? When you started, so started from here, the truck started from here. Then 1 hour, if you plug in 1, will be 24 minus 4. That would be what? 1 hour would be 20 miles, right? Then 2 hours, you plug in. After 2 hours, that would be what? You type in 2 to the square 4, 96 minus 832. That would be what? 64, right? Total would be what? 64 miles, right? So that means what? A little bit longer. So 64 miles. So that means the first hour, it drives 20 miles. Then second hour, it only drives 44 miles because 64 miles is the total. Okay? Then third hour, if you plug in, right? Then it will be, probably total would be plug in 44,108. Okay, third hour you plug in. So it means third hour, it drove 44 miles. Okay, then another hour, then you plug in at 4, then total would be, let's see, 88, 20, so it will be 128 all the way to here. That means it drove 20 miles again, all right, in 6 hours, right? Then when we plug in the 5, you actually plug in the 5, then you will find out is negative 28. Then, okay, because you drive, that will be total distance, and they'll be driving this way. Okay, because we just plug in S1 is 20, X2 is 64, X3 is, we just do the analysis, okay? 128, S5 is 100, then S6 is 0. When we plug in all the numbers, then if we look at the picture, 20 miles, 64 miles, 108 miles, 128 miles. Then for the 5th hour, it end up what? 100 from here to here. That means what? You lost 28 miles, means you are coming back. And S6 is 0 when we plug in this model. Then let's take a look. The question, first one, it says, find the velocity of truck after 2 hours. Okay? After 2 hours is at this point. What's the speed of the truck? You see, first you started, then you speed up because you increase your speed, right? Increase in an hour, second hour is 44 miles. You must, speed up. Then this one, another speed up, okay, to 44. So, let's see. It doesn't look like speed up much, right? Let's take a look. So, let's do the velocity. So, velocity is what? The derivative of st. So, we do that. Velocity equals derivative of st, which you take a derivative, that will be what? 48t minus 20 squared. Okay? So, we say after the second hour, so from here you speed up, right? Then you drive the same distance, you start to use the same speed. Then figure out what kind of speed is that. So you plug in your 2. So which will be what? 48 miles per hour. That's what it's saying. Okay, so here you speed up, right? From 0 and to 20 miles in an hour. Then you speed up again. Then at that speed, at that time, okay, then you start to what? It seems slow down, right? Then when you come back, it must be 0 here, right? The speed. Then come back here, you speed up, negative number though. So then you speed up. Okay, let's see. Next one, it asks you find the velocity of a truck after 5 hours. So you just plug in where it is what? That means at this point of time, at the 5th hour, its speed is what? Negative 60 miles per hour, because it would drive total 100 miles here in an hour. Look at that. Must be very fast. But the starter from here is what? 60 miles per hour westbound, right? Then next question, find the acceleration of truck after 1 hour. So what kind of acceleration after 1 hour? Must be speed up, right? So acceleration is what? The derivative of the velocity. So that would be, take a derivative here, would be 48 minus 12t, right? Then you plug in, I shouldn't have prime. A prime is what? I should write it this way. A prime is v prime of t, right? That would be 48 minus 12t, right? So we do A at 1 hour acceleration. You plug in, means what? 24. What does that mean? Okay, so after the first hour, after 1 hour, what happened? The acceleration is this way. Okay, the acceleration of the truck, right, is what? 24 your speed miles per hour squared. Because speed is 24 miles per hour. Is more than that, of course. Actually, it's somewhere here, right? But you speed up more with 24 miles per hour squared. That means what? It is speed up. Right? Because apparently after 1 hour, it has to speed up from 20 miles 1 hour to 44 miles in 1 hour. Right? It's about, this hour is 44 miles, this 1 hour is 44 miles. First hour is 20 miles. In 1 hour, you increase what? 24 miles. So that's your acceleration. All right, just to say, we use those derivatives besides what we have been talking about for business. We use for a lot of other things in engineering world and all the other fields as well.